Good morning, students. So, today we'll see the left out topic in lecture 3, maintenance energy for buildings. So, maintenance energy refers to the energy spent to meet the needs of the occupant of the building. So, this is mostly electrical energy. So, electrical energy may be used for lighting, air conditioning, water pumping, and operation of elevators. And in residential buildings, the other types of energy expenditure, such as use of ovens, water heaters, TV and entertainment electronics, computers, etc. And there's a need to understand the nature of energy utilization in embodied energy and maintenance energy in buildings, since developing countries like India have limited energy resources when compared to the large population. So we have a very large population, but the energy is less or limited. So hence we have to properly manage it. Next, moving on to chapter 2 of syllabus, building materials, sources, methods of production and environmental implications. So this is actually environmental implications of building materials. So before we move on to the environmental implication of building materials, we have to understand that the production of building materials leads to environmental or health related problems. So a particular building material can lead to an environmental impact either in the form of pollution or health hazard, or it can lead to the depletion of natural resources. Secondly, during the production of building materials, we use fossil fuel energy. So this leads to global environmental problem like global warming. Now let us see what is global warming. So global warming is nothing but increase in temperature around the globe, and this arises mainly due to two reasons. One is excessive burning of fossil fuels, and the second is deforestation, because there is no possibility of removal of carbon dioxide emission by the trees if there is deforestation. So excessive burning of fossil fuels and deforestation leads to global warming. And again, you have to understand that there was a Kyoto Protocol which was agreed by several countries across the globe to reduce the consumption of fossil fuels, but then it has not been done as decided. So now we'll see the environmental implications of cement. So cement, as we know that it is an important component of concrete. Without cement there is no concrete. So there is increasing cement demand, and the cement demand is directly associated to the economic growth, and there is tremendous cement production. But then the higher production levels of cement leads to a negative impact on the environment. So there is large emission of carbon dioxide. So you already know that if there is large carbon dioxide emission, there will be global warming. And again, the production is a highly energy intensive process. So it is said that the cement manufacturing industry represents 5 to 7% of the total carbon dioxide anthropogenic emission. Anthropogenic means which is caused by humans or their activities. So the total emission, carbon dioxide emission, so in the total carbon dioxide emission, 5 to 7% is contributed by the cement manufacture industry. Again, what is cement? We all always know that it is a finely ground non-metallic inorganic powder which when mixed with water forms a paste that sets and hardens. So next, the cement production. You already know about the flow chart. You already studied in construction techniques, equipment and practice, as well as concrete technology. So this is a flow chart for manufacture of cement. So again, the raw materials of two types, calcareous and argillaceous. So calcareous means limestone or chalk, and argillaceous clay or shale, shale. So there are two processes for manufacturing of cement, wet process and dry process. So this flow chart, if you draw this flow chart, is more than enough for the process of production of cement. So coming again, So cement is produced from raw materials such as limestone, chalk, shale, clay and sand. These raw materials are quarried, that is collected from the natural source, crushed, finely ground and blended to the current chemical composition. After the mixing, grinding and homogenization of raw materials, the process of calcination is followed by burning the resulting calcium oxide together with silica, alumina and ferrous oxide at high temperatures to form clinker. So we all know what is clinker. Clinker is then ground or milled together with other constituents like gypsum, slag, etc. to produce cement. So production of cement is known to all. So draw the flow chart and explain the process as I given it simply. Now again, what is the environmental impact associated with cement production? So following the environmental impact associated with the production of cement. First one is consumption of raw materials. Second one, consumption of water. Third one, consumption of energy. Fourth is the most important one, emission of harmful gases and VOCs. Fifth is noise emission and sixth is bad odor. So consumption of raw materials. So cement manufacture is a high volume process which consumes large amounts of raw materials. This leads to depletion of natural resources. So this creates a negative impact on the environment. Second, consumption of water. During the various stages, water is needed. So again, water is important resource. So again, that has a negative impact on the environment. Consumption of energy, we already seen that production of cement uses both thermal energy and electrical energy. So this energy is being used by the cement manufacturing industry. It is not available to society. So that is a negative impact on the environment. Now coming to the most important one, emission of harmful gases and VOCs. So during the various stages of cement production, these are some of the harmful gases which are emitted. Oxides of nitrogen, NOx, and other nitrogen compounds, sulfur dioxide and other sulfur compounds, total organic compounds including volatile organic compounds. So VOC stands for volatile organic compounds, metals and their compounds, carbon dioxide, hydrogen fluoride, HF, hydrogen chloride, HCl, carbon monoxide and dust. So the emission of harmful gases not only deteriorates the air quality, it also has a negative impact on the human health. So the large carbon dioxide emission results in global warming, ozone depletion, acid rain, biodiversity loss, reduced crop productivity, etc. So again, scientific evidence shows that contact to such harmful gases can lead to itchy eyes, respiratory diseases such as tuberculosis, asthma, chest discomfort, and even premature death. And if the acidic compounds are deposited on the earth's surface, they can affect the water quality of different water bodies and they can lead to acidification of lakes and streams. So if there is acidification, low pH and other chemical changes, it affects the survival of fish and other aquatic species. So this is a effect on the biodiversity and biodiversity loss. And again, the principal harmful effects of VOCs, volatile organic compounds or toxicity, possible contribution to smog. We already know what is smog via photochemical reactions in the atmosphere, possible contribution to the greenhouse effect and consequent global warming. So global warming is important and which we already discussed. And dust emissions can be directly linked to respiratory problems such as tuberculosis and silicosis. SILICOSIS. That is also a disease due to dust emission. So if the workers inhale the dust, they can have this disease. And noise emission, we already know that there is heavy machinery and large fans are used in the various stages of manufacture of cement. So this give rise to noise and vibration emissions which affects the health of the workers. And lastly, there is also bad odor, foul smell due to the gases emitted. And the cement manufacture indirectly affects the life of plants and animals. So if there is any death of plant and animals, the possible bad smell can occur from their death, from the decay of the dead animals and plants. So this is the environmental implication of cement. So today we have seen what is the maintenance energy of buildings, and also we saw the environmental implication of building materials cement. Thank you.